Sometimes, there we go. Now it's recording. Okay. All right. Again, it seems like I say this for every single worksheet, and I probably will for every single worksheet. You've probably already done this before. All right. But that's why we're doing an algebra review, because some people know it. Some people forget it. Some people never learned it in the first place. Okay. My guess is most of you probably learned it at some point. Whether or not we can do them, sometimes it takes a little refresher, and that's why we were doing this. Okay, we've talked about that a lot. All right, let's talk about a couple things here. It says combining like terms. Sometimes you'll see books, and they'll call this section adding like terms. All right, because that's what we're doing. We're going to combine them, and then we're going to add them together, or subtract. Because subtraction really is the same thing as addition, isn't it? Because what's subtraction? Adding the what? Opposite. Remember that? Adding the opposite? All right, so subtraction and addition are kind of the same. Subtraction is just adding the opposite. So adding like terms or combining like terms, however you want to say it. Well, let's first of all talk about what a term is. Then we'll talk about what like terms are. So a term could be as simple as just a regular number. Okay, just one single number. I don't know, 5. All right, that could be considered a term in algebra. All right, a letter, a variable. That's what we call it. All right, so what's like the most famous variable we use in algebra? X. Okay, so that could be a term. You could combine them together, put 5x. That whole thing right there is one term. It's not two separate terms, all right? It's one term. The terms are usually separated by a plus or a minus sign. So if you had a plus right here, how many terms do I have right now? They're separated by plus or minus, and I said this could be a term, this could be a term, or this could be a term. So how many do we have? What? You don't see it? 3. The 5 is one term. The x is another term. And what else? The 5x, the minus 5x is another term. So how many do we have right now? We got 3 of them, okay? You could have other terms that look like this. Like 3, let's do it like this. 3ab cubed, all right? I'm just making stuff up, all right? That could be a term, all right? So if I put a plus in between them, how many terms do I have? 1, 2, 3, 4 terms, okay? Can I add any of them together? You know what? I should have done this. Let's change this. Let's change this to a y. Is that all right? Thank you. So do I have any like terms? It says adding or combining like terms. Like terms means they need to be exactly the same, except for, I'm going to give you a word here. Do you see that number in front of that variable? Do you see this number in front of those variables? We have a name for that, okay? And I'm going to use that word, so I want you to know what I'm talking about. So the number in front of the letters, we give it a special name. Starts with a C. Anybody remember that? C-O. Nobody? C-O-E. There we go. Coefficient, all right? So we call that a coefficient. So 5 is a coefficient. 3 is a coefficient. In order to be a like term, the coefficients can be different, okay? But the rest of the term, all the letters, all the squares, the cubes, all that, have to be exactly the same. Did you hear what I just said? The coefficient can be different. For instance, if you're going to add apples, okay? It's a simple little thing that math teachers like to use all the time. I don't know why. They count apples, all right? So what if I had 3 apples plus 5 apples? Could I add that together? If I had 3 apples and 5 apples, could I add them together and get a certain amount of apples? Yeah. So what do? I just add the coefficients. So what are the coefficients? What's the coefficient to this one? What's the coefficient of this one? Okay, so you add them up and you get 8, and then you just keep the variable, okay? Keep the variable the same, or keep the rest of the term exactly the same. So it's just what? It's just a. So I don't go a plus a is 2a. I don't do that. You follow me? All right, if I got 3 apples plus 5 apples, what does that give me? 8 apples, okay? Can I add 3 apples plus 5 bananas? I can't. Now, some people have told me in the past, yeah, Mr. Henry, you can. You got 8 pieces of fruit. Yeah, but that's not just apples or just bananas, is it? Okay, can I add these together and get 8 of like one thing? No, all right? So these are not like terms. Why are these not like terms? because this has a B and that has an A. The fact that the coefficient is a different number doesn't make any difference. It just says how many of those things you have. All right, that's all the number in front says. I got 3 apples, I got 5 apples. I still have apples, right? I just have a different number of them. So the number in front, the coefficient, can be different, but the variables and the squareds and all that kind of stuff, okay, have to be exactly the same. All right, enough of that. Let's do a couple examples from the worksheet that I'm going to give you today. And actually, the worksheet's very, very simple. Most of them, the first 20 anyway, you can do without showing any work. You should just be able to look at it, boom, write down an answer. Just do it in your head, write down an answer, okay? Now, from 21 to whatever, what's it go to? 30. From 21 to 30, absolutely, you got to show some answers. So let me just do a real easy one for you first. I'll just do the first one, okay? This is the first one on the worksheet. I'll call it example 1. But it is the first one on the worksheet. It's negative 6k plus 7k. I almost don't even want to do that because we've kind of already talked about it. So what do? You add the coefficients, and then you just keep the term the same. All right. First of all, are they like terms? Yeah, because they both have k. The fact that one's got a negative 6 and that one's got a 7 doesn't make any difference. That just says how many k's we have. All right. So if you add them up, negative 6 plus 7. What's negative 6 plus 7? It's 1, and then 1 what? 1k. Now, we don't have to write that 1 there, do we? If there's just 1k, what's really a nice simplified way to write the answer? Just k, and that would be your answer. Make sense? Yeah, pretty easy. All right, let's do another one. Let me see. All right, we'll do another one. We'll do this one. I'll call it example 2. Even though it's an exact problem from your worksheet, I'll put n plus 4 minus 9 minus 5n. By the way, before we get into this, here's another vocab word. I don't know if you probably heard it. You may not remember it. But when you have a number just sitting there by itself, we got 2 numbers sitting there by itself, don't we? Without a variable attached to it. When we have a number just sitting there by itself like this, we give it a name and we call it a constant. Why do you think they call it a constant? Doesn't change. Very good. I like that. Exactly right. It doesn't change. It stays the same. So positive 4 is always going to be positive 4. This is like a negative 9 or a minus 9, negative 9. That's always going to be negative 9. Well, n could change depending on what number n's equal to, right? I mean, we don't know. N could be anything, right? So we call that a what? Anytime you have letters, what do we call those? I've said it a couple times already today. What is it? A variable. Very good. Why the word variable? Because it varies. It could change, right? So when you have a letter, like right here, that's a variable. Let's write that down. All right, so that's a variable. That's a constant. What about negative 5? Is that a constant? No, because it's multiplied by a variable. So that whole thing, that whole term could change depending on what n is equal to. But negative 5 is a what? Coefficient. Very good. What's the coefficient to just this n right there? It's just a 1. That's right, because you could have a 1 right in front of it. 1 times n is n, isn't it? Yeah, so even though you might not see it, the coefficient is 1. All right, let me get rid of all that mess. And let's do the problem. Because sometimes we got to talk about what words mean so that we're speaking the same language. Agree? All right, so let's do the n's. All right, see if there's any other n's, since that's the first thing. Are there any other n's there, Josh? What's that? The n one, is that what you said? Yeah. So I got 1n, what? Yeah, you can add the things with the n. So this has 1n, and this is what? Minus 5n. So what do? Add the coefficients. What's 1 minus 5? It's negative 4, right? So watch. 1 minus 5, what do? For subtraction, add the what? Opposite, right? So what's the rule? Subtract takes the sign of the bigger number. So we subtract, we get 4. The sign of the bigger number is negative, so it's negative 4. But not just negative 4 what? N, right? Because of the n right here and the n right there. Sometimes when I'm done with them, I like to mark them off so I know I'm done with them. You don't have to do that, but I like to do that. All right, what about this? These are just constants, right? They're like terms, okay? Anytime you have just regular numbers, you can add them up, all right? Yeah, it technically is subtraction, but you could go add what? The opposite, right? And so you subtract, take the sign of the larger. What's that? Negative 5 or minus 5. And then that would be your answer right there. Piece of cake, right? People say piece of cake anymore? Sound like an old guy saying that. But that's all right. I am old, so I'm allowed to say it. I got no problem. I see a lot of old people trying to talk like they're young, you know? I just think that's weird. Do you? Yeah, like an old teacher, somebody in their 50s trying to use the slang of today. I don't know. I talk the way that I was brought up talking, so I might use some old corny phrases, but that's okay. All right, let's see. Okay, here's a good one. Let's do the one where you have to show some work. Like that problem we just did you have to show any work? Nah, you just look at it, boom, write down the answer. All right, this one, is this example 3 or 2? I don't know. Whatever it is, it doesn't matter. Let's do it. So negative 4 plus 7. Now, here's something new that we haven't talked about this year. Now, hopefully, you know how to do it, but I'll teach it to you if you don't. All right? By the way, I don't think I said this, but all these say simplify. I should have put that at the top. It says simplify. All right, because you can add some like terms. All right, so they all say simplify. All right. What do we do here? Do I go negative 4 plus 7 is 3? No, because what's that 7 doing to that parentheses? It's being multiplied, right? But look inside the parentheses. Now, before, I could add up the stuff in the parentheses. Can I do that now? Are they like terms? No, this is a constant. This is just a number, and that has an m with it. I can't add those together or subtract them. So I got to do something else. So all you guys that took algebra last year, you know what to do? You do something with that 7. How do I multiply that 7 by that entire parentheses? There's a word for it. It's a property. I'll give you a hint. That's half of it. Starts with a D. I bet you anything once I say it, you're going to like, oh, I remember it now. Watch. What if I do this? I'm going to take that 7 and multiply it by everything in the parentheses. Do you remember that? Yeah. Starts with a D. DI. Nobody? It's called distributive property. You ever heard of that? Yeah. I'm almost guarantee. If you took an Algebra 1 class, no matter how bad or how good, I bet you anything, you've heard of this word distributive property. I'll just put prop for property. You distribute, right? You give it to one. Like if I was distributing $100 bills in here, which I'm not, don't worry. But if I was going to distribute, I would hand them out from one to the other, to the other, to the other. Yeah? Well, what are we doing here? We're distributing the 7. We're multiplying by 7 times everything in the parentheses. All right? So we're not doing anything with the negative 4 just yet. I'm just going to write negative 4. Then I'm going to put a plus because that's going to be positive. Now, what's this going to be? 7 times 1. What's 7 times 1? 7. And then, watch, I got a positive 7 and I got a negative. What's my sign going to be? It's going to be negative. Then it's going to be what? 7 times 3, which is 21. But then, what about that m? We just write it down right next to it. So we didn't really talk about how to multiply. So if I had like 3 times 2x, how do I multiply those together? I just multiply the numbers, the coefficients, right? We'll just say the numbers. And then I just include the term. So that would be what? 6x. Okay? What if I had this? What if I had 3y times 4x? What's that going to equal? Well, just multiply the numbers first. So what do we get? 3 times 4 is 12. What do I do with the x and the y? Just write them down, put them together. Exactly right. You could put yx, and it wouldn't be wrong. I wouldn't mark it wrong if you did that. But what's a better way to write it? xy. Yeah, we usually put it in alphabetical order. It just looks a little nicer, a little cleaner. So that's how we multiply. And that's how we multiply those. Now, we didn't even do any add-like terms yet, have we? Now we're ready to, okay? So this is a step that you have to show. All right, if all you give me from 21 to 30, if all you do is write down an answer, I'm gonna say what? What am I gonna say on there? Show your work, okay? Depending on how I feel, how many problems you didn't show your work on, depends on how, like I had honors algebra 2, right? Honors algebra 2. You'd think all the honors kids would show their work with all the problems. He gave me a whole entire piece of paper, and every single problem, except for 3, you had to do like 3 or 4 steps, at least 3 or 4 steps, all right? Every single problem, all he did was just write down the answer. How do you think he did it? Do you think he did that in his head and wrote it down? No. What did he probably do? Well, not even a calculator, because there's X's and Y's and all that kind of stuff in there. But what do I do at the beginning of class with your homework? I read off what? I read off the answers. And so he probably just wrote down the answers as I read them off. Okay? It's not hard to spot. I took off -4 for his. I should have taken off -5 and given him a 0. But at least he turned something in. All right? So I gave him 1 point out of 5. All right? So it's important that you show your work, right? And this is a step right here. And that's an honors class. And usually I don't get that in my honors classes. So let's do this. What can we do? Any like terms here? Yeah, I got regular numbers, or what? What's a regular number called? A constant, right? So I add those up. -4 plus 7 is 3 minus what? 21m. Now, can I subtract those together? No, I can't. Why not? Because they're not like terms. Exactly. Perfect. All right? You guys are getting the hang of this. And that's your answer. You just leave it like that. Okay? If it is a like term, you would add the like terms. You always add like terms. When it says to simplify, if you didn't add the like terms, you didn't simplify it. Okay? So you make sure you do that. So first of all, in this one, you had to distribute to get this. Then you look at it, add your like terms, and you're good to go. Really, there's nothing else. There's a couple where there's like 2 sets of these in one problem, where you got to do 2 distributive property things. All right, but really the math is pretty much exactly the same, and most of them towards the end. Well, actually, there's a few at the end. There's 5 of them where you get 2 sets of those. We got a couple minutes. Let's do one of them. Is that all right? Let's do this one. Example. I'll call it example 4. So let's write this one down, and that will be finished. So we got -10. Got 1 minus 9x. Let's write this down. Shouldn't be any talking. Everybody should be looking up here and writing it down. Nothing to talk about. You can talk during lunch. All right, here we go. I would normally give you time to work on it on your own, but we're running out. We're running short on time, so let's do this. So what are we going to do with that -10? Distribute. Right, multiply. That's true, multiply, but more specifically, distribute. Okay, so let's do that. -10 times +1, -10. -10 times negative. See, this is a negative right here, right? So negative times negative is positive, and that's not 99, but just 90. 90 what? X, because you got that X there. Plus, now we're going to do another distributive property. That's 90, right? 10 times 9 is 90. Why is everybody saying 99? I don't know. You're making me doubt myself. So what's this? Plus what? 6x minus what? You got to take, no, look at the arrows. This 6 has to be multiplied. Right, it's 60. Right, you can just do that in your head. Don't write 6 times 10. Just do it in your head and write it what the answer is down. Now, we haven't done any like terms yet, have we? Now we're ready to add like terms. Let's take the 10. Well, since that's the first one, let's do that first. Are there any just regular numbers here? The 60, right. So it's -10 minus 60. Let's write it off to the side. -10 minus 60. Remember how to do that? Add the opposite. That's -70. I'm done with this one, done with this one. Let's add these 2 like terms. What do we get there? That's easier. Plus 96 what? X. Right, because they're like terms. It's got an X, so you put an X there, and you are done. That's all you got to do. Yeah. What's that? It should be like any minute, I think. 21. So yeah, the bell's about to ring. All right, so make sure, I got to give you the worksheet. Don't leave. Let me close this out.